Welcome to part 3 of the AIWA tape deck repair. Hopefully this ends as a trilogy and doesn't end like Game of Thrones. The motor's been totally rebuilt, mechanism fixed, and now we're chasing some errant noise which has ballsed up the Dolby Auto-detection. Well, the Royal Mail have finally come good and delivered the spare parts I was waiting for. And another good bit of news, my vintage scope fixed itself. How's that happen? Just probing the source of noise on this Auto Dolby board. The playback signal passes through a pair of low pass filters before going into these tone decoders. And we've got a lot of noise coming out of this 2.7 Hz low pass filter, which isn't there if you disconnect the signal, so it's here. And that takes us straight back to this playback amplifier. I didn't have the right op amp chip before, but I have now the NJM2043S, which I'm hoping cures this noise issue. We'll see. Let's turn it on. Oh, not hearing much noise. Well, the motor's not going round. Oh, don't you start that again. This motor's caused too much trouble already. Is there any voltage on it? Oh, no. Oh. That's a 12 volt supply that's gone down again. What's happened? This appears to be a bit of a recurring failure. We had to replace this fusible resistor before. Surely not again. These two series Zener diodes are shown there. They regulate the 12 volt supply. It's difficult to probe around here, it's a bit tight, but here's that fusible resistor. It's got the voltage on there. These Zener diodes. Oh! It's working. Measure the voltage on here. Yeah, 12 volts. I think we got dicky diodes. Let's cool them down a bit. Oh, it just stopped. Did you see that? There we go, it just started up again. Well, the back cover's going to have to come off again. Can't quite get at them. Oh, I really don't like how flimsy this is now. That board's holding everything up. That's them there. I don't know if it's one of them or both of them, but yeah, I'm going to change them. Clean those holes out. So what have we got? 4 volts and what's this? 8.2 volts. Well, 4.3 volts is the nearest one I've got, so I'm just going to lightly twist these together if I can. Not too much. Put those in. Here we are, factory correct bodge. Let's get this the right way up. It's a bit wibbly wobbly. Line the tang up with a little hole. Just pull this chassis into shape. Power it back on. It's still not running. Maybe they weren't dicky diodes after all. There's definitely something round here. That resistor, that's for the base. Oh look. Every time I press it. Got to take the back off again. That's the offending resistor there, 330 ohms, the measure's okay. I think I have a broken track somewhere. I can't see it being this resistor, not really. It could be flexing the board when I press on it. Maybe this transistor. Is that a tiny bit of movement I'm seeing? And I whip this out. I wonder if we've got a broken track. Well, that's not showing any broken pads, which is what normally happens when the track's broke. But do I see a little fractured solder ring there? It is. Well, you can barely see it. Just re-solder that then. Better put the transistor back in then. Let's try that then. That sounded better. Give that resistor a little rattle. No problems now. Perfect. So where were we? Oh yes, I just changed that chip. See if that noise has gone. We just probe pin 1 off that cap. Yeah, well there is noise still. Not as bad as it was. Let's test the Auto Dolby out. Type B. Record. Play. Oh dear. That's worse than before. That's a familiar racket. I'm going to try some freezer spray on there. Gone quiet a bit, that screen's not looking good. It looks like the new NJM2043SA is doing exactly the same as the original one. I'm going to try a different chip altogether. For a bit of a sense check, I'm going to put in something more conventional. I quite like the TL072. It's a nice op amp, low noise as well, but it doesn't look like that. So I'm going to have to make a little adapter board. Just going to use a piece of Vera board. It's already got copper strips on there, and I've already drilled out 4 spaces there so I can put the chip across there, don't shorten the legs out. Just poke the legs through these holes, like that. Then I can use this header, right angle pins, and can solder it to the board in the style of the original thing. I like to use a bit of blue tack, or whatever this is, a rival of blue tack, to hold the components in place. Just going to put some wire links in. There we go. I need to skip pin 1, so it's not actually connected to anything. There we go. Let's see how it likes that one. Well, that's not an improvement. Oh wow. Yeah, I think that's even noisier. Let's have a look at all the dual op amps, see what the best one is I've got. And I reckon it's this. And this is the data sheet for it. It describes it as an ultra low offset voltage dual op amp. Very high DC precision. This sounds really good. It's got to be worth a try. Let's take this noisy op amp out of here. It's not helping. And out it comes. And in goes the poshest dual op amp I've got. The AD-F990. I've got high hopes for this one. See how it works. It's about as good as we've seen today. I'm going to leave it in. Okay, the Dolby test. Set type B, record, play. That looks more promising. I recognise those sine waves. And the output looks pretty good compared to the source. Yeah, needs a little bit of calibrating again. But yeah, pretty good. Let's try Type C. I think we're in the shout with it's working. The moment of truth, can it detect its own Dolby signals? It's found it, Type B. We haven't got any flickering. This is looking good. The sine waves are looking good on the scope as well. I think we've cracked it. Coming up for C-type now. Yes, perfect. I'm calling this one fixed. So that's sorted now. So the last thing to look at is the COMPUBRAIN system. I think they eventually dropped the COMPUBRAIN name and called it D.A.T.A. But whatever they've called it, it calibrates itself to the tapes. Let's try it. Oh, well, it looks like it's calibrated the bias and nothing else. It's given up. Now back to the service manual, because there is calibration for COMPUBRAIN. There's not a lot about this. It's all written in this little box here. That's it. It's telling me the test points are TP8, which is on this little board here. You adjust it using a potentiometer, SFR1, OK. You have to replace the wire from the A to the B and connect the resistors that are on pins 12, 13 and 14 of IC11. So this is the main board, and the points of interest are SFR1, where the resistors go, laid out like that. The test points are there. This is our waveform, like a square wave. Where's wire A? Oh, here they are, A and B. It's behind that board somewhere. Let's take our probe off here, finish with that now. Just hook our probe onto the test point. I've soldered this pair of 4K7 resistors to these connectors, so I can just fit them on here. This must be position A. It doesn't say the letter A on there, but it's in the right place. Point B is down here somewhere. I can't see it. There it is. Got a torch on there. Yeah, just in front of that cap. We're on. It's reading 0 volts at the moment. So adjust this pot, SFR1. Oh, it's gone high. Oh, low, high, low. Oh, God, this is sensitive. Crikey. Oh, it's like nearly there. Oh. Now I'll see why it's not calibrating. I'm going to steal an idea off this power supply. It's got a coarse and fine adjustment pot, so you dial it in somewhere close. So if I want 10 volts, it's difficult to get it exactly on with this coarse knob, but then you use the fine adjustment, you can get it pretty much bob on. So this trimmer is a single turn trimmer. It's 100 kilo ohms, quite high. So if I insert another pot that's say 10 kilo ohms, it'd be 10 times more sensitive. Just got to work out where to put it. The schematics are quite small in this service manual. You can see the potentiometer here comes out of pin 10 of this chip, then through a little capacitor, C19, and it goes out elsewhere. And that includes wherever this goes, which is right over here. Oh, blimey. I decided to draw out the circuit like this instead on the whiteboard, but easier to follow. So what's going on? There's a chip here, IC13, whose job it is to create a 1 kHz test signal, 2 volts peak to peak. And when we put those test resistors in, it switches this here, passing this signal straight through this potentiometer, through this capacitor, then it goes off to different parts of the circuit. It's interesting to note that point B that we connected to is one of the outputs from the Dolby record board. So we can put our trimmer anywhere between here, or here, there or there. Which is anywhere around the vicinity of here. This is IC11 and these are the test resistors, or the test points, pins 12 to 14. If we look for pin 10 we go 14, 13, 12, 11, 10. Follow that trace. It goes to the potentiometer just like it's supposed to. This leg and this leg are shorted together. Okay, so we can either break a track here, we can follow it from here. This goes to this capacitor here, which is C19 down here. So where does it go? Follow this track around the bottom here. It goes up there. This part here. Well, I think that's a wire link there. That's handy. we could take that out and sneak our pot in there. I'll grab out the tweezers in case it's a bit hot or stuck. There we go. I've actually found a 10 turn pot here, 10 kilo ohms. That's going to be perfect. That'd be very sensitive. What I need to do though, just need to bend the legs so two of them are shorted together. Pop a bit of solder on there, make sure they're well connected, and just pop it in here. Power it back on. Let's get some course adjustments in. Of course it's not very far off. Okay, just get it closing in. Look at those square waves. Trying to get them as even as possible. Oh, back a bit. There we go. Beautiful. Not as stable as I'd like, but at least it's oscillating. That's something. Pull our resistors off. Let's take our Compu Brain measure lead off and put it back on position A. Let's try it now. Still the same. From what I've read about these tape decks, they're very difficult to get right. There's a few things you need to check. And there's a lot of noise about power supply noise, and that comes from the capacitor police. But I like to check the power supply rails first. This tape deck's got a dual rail 7.5 volt supply for all the analog stuff. That's the important part. I'm going to probe pin 8. That's where the positive rail is. 7.648 volts. 320 millivolts peak to peak ripple. I'm not sure that's even true. Let's take the probe off. Still says that when I'm not touching anything. Try the negative rail on pin 4. Yeah, 7.653 volts. I can't see any ripple despite what this thing says. Let's zoom in on that ripple, AC coupling, and just wind this right in to say 20 millivolts. So pin 8. I say that's about 10 millivolts of ripple there. Just a bit of noise, nothing really. Negative rail. Yeah, the same. Yeah, I don't know about those spikes, don't know if I believe them. I get the same ones when I touch the chassis. So I don't think it's a power supply problem, but there's a lot of adjustments to make. So for an experiment, I'm going to put all the potentiometers back to their mid positions. And then I'm going to measure the output for different types of tape. This one's a normal bias. It's got about 2.8 divisions on the bottom, and what's this? About 1.9 divisions for this one. Now I've got a type 2 or a chrome tape. It's a lot less actually. This one, about 2.2 divisions. And this one up here, what's this? That's loads less. 0.8 divisions. Now I've got a metal position tape. Quite expensive these are. Very similar on this channel, about 2.4 divisions. This one's not even, oh, that's about a third of a division. Each one of those tapes had a progressively faster EQ, so they got a higher frequency response, and something wrong with the right hand channel, definitely. And just to prove it's just a recording problem, here's a commercially recorded tape. So there's nothing wrong with playback, very healthy. And this is the calibration procedure for all this, and it refers to lots and lots of different test tapes you need. I've actually listed them out. It turns out there's only 5 different ones. Unfortunately, 3 of them are blank. The first step of electronic calibration, part 3 here, is to adjust the frequency adjustment. That requires a test tape with a 10 kHz and 1 kHz signal on there. It's pre-recorded and I haven't got one. I'll have to skip this step. Step 4 is a playback sensitivity adjustment, again requiring a pre-recorded tape that I don't have. And all these trimmers are set to the middle, and to be fair, it played back okay, so it can't be far off. I'm also going to skip the meter adjustment because I actually don't think there's much wrong with them, and I doubt they've got anything to do with the problem we're experiencing. So the first thing I can look at is a bias oscillator. Check it's running at 85 kHz. We can pick that up on this wire here. Press record. It'd help if I put a tape in. Well, I can't see the measurement. Let's zoom in on this. It's quite a high frequency, 85 kHz. We've got 84.9. I'd say that's close enough. How do I shut that up? No, it's better. Now on to step 7, bias oscillator output adjustment. And I need to put a type 2 tape in there, a chrome one. Then adjust the measured voltage down between minus 3.8 to minus 4 volts. Okay. Put the chrome test tape in. Take our test lead off this test point. And onto this one. Zoom in a bit. 1 volt per division. So I can get this line adjusted to the bottom of the screen. This is L505. Oh, that's the wrong way. It's coming back up. Oh. It's already set at minimum. Nowhere near where it's supposed to be. Onto this test position. Oh, it's off the screen. Where is it? Oh, there it is. And on to L506. Can I adjust it? Oh. No. That's having no effect at all. Okay. So I think we're closing in on this. To try and understand it, I want to see where this test point is in the diagram, see what we're measuring and what we're adjusting. We're actually adjusting this here, L505 and L506. I don't see a test point 5. We'll trace out a left-hand channel first, because that's what's shown in the diagram in detail. So this is our test pin, goes through a wire link, and follow this track, it snakes around here, comes up there, onto pin 8 of IC502, the record head amplifier. And there's pin 8 and it says test point 7, so that's wrong. It's test point 5. So the complementary output on here is pin 2, which is here, so if we trace this signal back, goes across the link there, snakes down here, yes, into our test pin. That's the one. Just looking to understand what we're actually doing when we adjust this. By turning this, we're adjusting the coupling between the two sides of this transformer. Literally, it's feeding a signal in from here, which is a centre tapping of the main bias transformer. And I pay to check the obvious things, like that there's continuity here. Yeah, 9 ohms, about this one, the other channel, 9 ohms as well. Okay, and this one, 1 ohm. 1 ohm there as well. So what we're seeing is this op amp trying very hard to drive this transistor. It's trying to get this to pull as much current as possible. There's something stopping it. I do see a fusible resistor, 47 ohms. And there they are, right next to these transformers. They look alright. Let's measure them. So this is the good channel. Oh, 235 ohms. What's this one like? 475. That's out by a factor of 10. These aren't the first fusible resistors we've seen drift high in this machine. So let's get them out. Let's fish these out. Back in the specialist resistors again. Looking for 47 ohms. There we go. Pull a couple off here. Wiggle them in, they're a bit awkward. Look at that. Beautiful. So will it calibrate now? Let's see. Power on. Put it into record. Well, that's instantly better. Look at that. See if we can adjust it a bit more. Oh, the wrong way. We're going to go for 3.9 volts, the midpoint of where the service manual said. Look at that, perfect. Let's stick it back on that other channel. So that wasn't right either. Well, that one's actually a little bit too far negative. I'll bring it back. Excellent. I won't waste your time changing caps on this machine. Just change all the resistors. How bonkers is that? So next up is bias strap adjustment. Got to put a metal tape in for this and pick up test points 6 and 7. Well, here's test point 6. I need to zoom in a bit here at 2 volts per division. I might wind the time base out as well so we can see what's going on the tape. Just make the adjustment, wind it in. Oh yes, just there. Let's pick up the other test point and make the same adjustment. Oh, it wasn't far off. Let's shut that up a minute. The next stage is to adjust the frequency characteristics. We've got to supply a 1 kHz source, adjust it to 38 millivolts on the line output, and then basically compare 1 kHz and 10 kHz signals and make sure that they're slightly different. I've got the line output connected to this old scope and it doesn't measure anything. And I'm also going to take these out from the amplifier because that's got a 47 kilo ohm resistance, which is dragging it down a little bit. Just going to pop this on here. So I can connect it to these multimeters. So what does 0.5 to 1 decibels of gain mean? Here's a definition of how a decibel is calculated from a ratio of voltages. But in our case, we need to know what the linear gain is. So we've got 38 millivolts times 10 to the power of 0.5 over 20. I can't work that out in my head, so it's 38 millivolts times 10 to the power of 0.5 divided by 20, which is 40.25 millivolts. And the upper limit, same calculation again, 1 dB. 38 times 1 over 20. 42.64 millivolts. I've managed to coax the line output to be 38 millivolts on each channel. You can appreciate that's difficult to measure accurately on an analogue scope, and this also needs standard type 1 tape in there. Now to change the frequency to 10 kHz on both channels. It's caused a slight increase in amplitude, but not enough. Although it helps if you press play. Oh dear, that's quite low. Well, that's not the 40 millivolts we're looking for. Let's see if I can adjust it. Start with this channel. Oh, that's making it worse. Go the other way. Oh. It seems to have a centre sweet spot. I wasn't expecting that. It was pretty much where it started. About this one. Yeah, same effect. Although this is not so responsive. It's about as good as it gets there. Just trying to figure out what's going wrong here. What this pot's actually doing is it's manually allowing us to do the automatic adjustment to the bias. But everything seems to be working very sweetly at 1 kHz, and I don't see exactly how this will affect the frequency response. The different frequency responses are required are done in the feedback circuit for the record amp. Each little individual filter network is called in by these transistors, depending on which tape's been selected. It's interesting to note that frequency response is adjustable for metal tapes. The different bias levels are switched by these transistors here, and there's not actually adjustable, they're just fixed with fixed resistors. I should check the output of the record amp just to make sure that we're not losing a signal there. Our signal comes out on IC401, pin 7, through here, through this capacitor. That'd be a good place to check actually. Could have a problem there, maybe. Start with the left channel, IC401, signal comes in on pin 3, there it is. Comes back out, pin 1, much bigger. and there's a 22 microfarad cap here. There's the signal on that side, and it's still there the other side. Nothing wrong there. A lot harder to get at, this one's with boards in the way, but pin 3 there, signals there, pin 1's the output. There we go. Looks pretty much the same. We've got a 22 mic cap tucked in there, signal, both sides the same. Perfect. I've got to mention that's at 1 kHz, so I'll do this one at 10 kHz. Let's check the left hand amplifier, input pin 3, there it is. Okay, pin 1. Whoa, loads of amplification. Yeah, there's definitely some EQ going on. Then gets that capacitor again. Yeah, that's good. This side. Yeah, no problems. And the right hand amp. Pin 3. Okay. Output. There it is. Then the capacitor. That leg. Yeah. And the other leg. All good. It looks like the recording amp's working, and that sounds like a good thing, but it's actually bad news. It means I don't actually know why this isn't working. There could be lots of things. It could be a bad tape. Could be the heads. I'm not sure. In a last ditch effort, we never managed to calibrate the playback EQ because I haven't got the factory tape, but let's see if I can adjust it right here. Let's look at the source again. We need our waveforms that big. It's not really helping much at all. Sweet spot's about there. What about this one? No, making it worse. Yeah, it's about as good as it gets. I'm not actually sure I'm going to be able to fix this problem, but there is different settings for the metal tapes. We've basically got to do the same thing again, but using different pots. So we stop that then. Put the metal tape in. There's our 1 kHz signal, pretty low level, so yeah, a little bit jittery, but you see the amplitude. You've got 28 millivolts there, 31 millivolts there. We can balance those up later. Just change this to 10 kHz now. And the level has dropped, but not as bad as before. Look at the source again. So we're looking for about 2 divisions vertically in each one. There we go. At this channel. As good as I can get it. Put this back to 1 kHz. Just check the source. Just got just over 2 divisions on each one. Just in the right channel first, because it's easy to get at. Now the left channel. Okay. So for the metal tapes, I've got the low frequency and high frequency response pretty similar, so we're in with a chance. But the CompuBrain does actually do a 13 kHz test right at the end. So here we go, 13 kHz, both channels. It does look very noisy compared to the source, but yeah, I don't know. Maybe. There's only one way to test this. I'll hook a probe onto this resistor here so we can see what goes on when you do a CompuBrain calibration. We'll keep our fingers crossed. It starts off with 400 Hz to detect the tape. Now it's switching between 1 kHz and 10 kHz. And now it's adjusting the level by changing the gain. It failed that time, restart. Comparing 1 kHz and 10 kHz waveforms. Now it's adjusting the gain. It passes that, the EQ is tested with 13 kHz. There we go. And it's failed. We didn't fully calibrate the tape because it fell over on the 13 kHz part, the final part. So I agreed that it shouldn't calibrate. So that's telling me that the CompuBrain calibration system it's actually working. If we just take this metal tape out, which is good quality, high bias tape, and put our bog standard type 1 in, will it calibrate that? I doubt it. Yeah, and now we know why. As I mentioned before, I don't know how I can improve that frequency response, and it could be the tapes. They are old, like 25 years old. I don't know what their lifespan is, but we're pushing it. Well, I think I'll take the tape out and we'll start the rebuild. Get the scope probe back out as well. Don't pack that in there. Get the test leads off as well. Stop them tangling up. It's been a while since I took this apart, so I'm just trying to remember how it all went together. I know these pots definitely poked for this chassis. Make sure they're on tight, so you can't get these nuts with the cover on. Try and get this metal chassis to line back up with the screw holes. That's about right. Let's get a screw in there. The same on this side. There's a lot of wires in this, and it's pushing back. Spring loaded. Let's push the headphone jack through the hole. There we go. Get the nut back on it. Preferably straight. Don't want to cross thread your headphone jack nut. Just give it a little tweak with a spanner. That'll do. Next is a timer select switch. Cable's only just about reach. Tiny screws in there. Not forgetting the little felt disc. Keep it looking smart. I'm going to feed the main switch through there. That's the right position. Then your jack button cap. That fits on there like that. Then the power switch cap. Just there. Getting this front facer on's a bit awkward. It's best to lift this up. Just wedge it on something. Then we can lift it into position. Then just give this a bit of a wiggle. And it should just find itself home. There we go. Let's get the screws in before it pops back out. Let's fasten the top of the tape mechanism in. With every screw going in, this is getting a lot less floppy. Now we can put the bottom cover on, which gives it the benefit of 2 more feet. Let's get these little plastic fixings back in and use the wire cutters just to squeeze them up so they can push in. Then just push these locking pins in. Put these knobs back on. I think this one's in the centre anyway. Yep. I don't know about the output level, so I'm just going to engage it there, turn it all the way down to minimum, take the knob off, and put it back in the minimum position. Little bit of a fiddle. Just clips on if you can get it right. There we go. Just a bit of housekeeping with the wiring. I seem to think it was sort of tied up. Trying to include all the wires I can. And on with the cover. Last time we've seen in there. And not a single screw left over, not even after all these months. Well, it's in better shape than when it first arrived. This tape deck's been a real ordeal right from the beginning. It started off with a seized motor which I had to rewind, and then we had a blown 12-volt power supply, then we had loads and loads of fusible resistors failing this thing. Then we had the issue with the mechanism, the take-up reels weren't working. That turned out to be a motor was installed backwards and needed some rubber parts replacing as well. We had the Dolby Auto-detect not work because not of one but two faulty amplifier chips. And now left with the issue for recordings where the high frequencies aren't high enough for the auto-calibration to work. I actually tried changing some components in the EQ circuit to see if I could correct for it, but I don't really know what I'm compensating for. Worn heads? Dodgy tapes? I don't know. But this thing, it plays, it records, and it's going home. Catch you next time.
Oh.